continuing in 15.3, and we're introducing the JK flip-flop. And here I have a little schematic symbol here, and this schematic symbol probably isn't the best schematic symbol, but it does have the all of the inputs and outputs that you would see on a JK flip-flop. Now, what you might note is some things are similar to what we looked at in the D-type flip-flop. First of all, we have the set and the reset, and we still have the Q and the Q0, and we still have the clock input. These are all things that you saw on the D-type. However, with the JK, we have two inputs that are, and these are going to be synchronous inputs, and we'll have a J and a K. And what are we going to say? J and K are synchronous inputs that determine the flip-flop's behavior when a clock transition arrives on the clock input. So again, we're going to have a clock coming in, and since we have this 0 here, that's telling us that this one's actually going to clock when the signal goes on the negative edges. Now, here we have the truth table for this device, and so with J and K, since there's two possible inputs here, we're going to have 4 possible states, 0, 1, 2, and 3. Now, the first one, if we had a 0 and a 0. Now, you'll notice our outputs, again, we have the Q n plus 1, which we had talked about earlier, which indicates the state after one clock pulse. But here, on this state of 0 and 0, we have this Qn, and there's no clock pulse present. So what this means is that it indicates the current state. And so if I have a 0 and a 0 here, and let's pretend that this was a 1 and a 0, the output is not going to change. In effect, when you have 0 and 0, the flip-flop, or the JK flip-flop, isn't going to change state. It's not disabled, if you will, but it is not changing states. It's going to stay in the state that it is in. Now, if we have a 0 and a 1, okay, let's just put a 0 and a 1 here, and we have a clock pulse, then the 0 and the 1 are just going to pass straight through to the output. So Q would become 0 and Q0 would become 1, and vice versa. If we had a 1 and a 0, a 1 and a 0 here on a clock pulse, it would just pass straight through, and we would have the same thing, the Q n plus 1, it would pass straight through. And if we had this state, if we had a 1, if we had a 1 and a 0 here, and we had multiple clock pulses, then this would just stay in this state indefinitely until the J and the K inputs changed. Now, if we have a 1 and a 1, now this is a unique part of a JK flip-flop. If you have a 1 and a 1 here, what the output is going to do is going to toggle, meaning that it's going to change states on every single clock pulse. So if on this negative going edge, if this is a 1 and a 0, on the next edge, it's going to be 0 and 1, and then 1 and 0, 1 and 0, 0 and 1, 1 and 0, on and on and on. So it's going to change states every time that there is a valid edge to clock it. And so this dictates the truth table for synchronous operation for a JK flip-flop. And as in the data type or the D type, if you have a value coming in on either the R or the D, it will override whatever the JK is doing. And this is a example from your textbook. This is actually figure 1525 in your textbook, and this is in your multi-sim package. It's 15_25 MSM. I encourage you to go in and run this simulation. This will give you a better understanding of a JK flip-flop. Here we have, it's just a very basic configuration. We have the JK set up. Let's look, we've got a ground at the bottom of the page. We have VCC 5-volt logic in this circuit, and we have a switch. And you can go in and press the letter D or the space bar, and you can activate or deactivate these switches. So let's look at the current state of the switches and evaluate what we have over here. So currently we have the D switch is going to ground, so that would put a 0 here. It goes through an inverter, so that would put a 1 on J, and that 0 goes down here and it puts a 0 on K. So we have a 1 and a 0 as an input. And then as the clock, let's see, this feeding into our clock, and this is going to be clocking on a positive edge, so this is going to ground, so that would put a low here. It's going through the inverter, that would put a high. So we have a transition from 0 to 1 when we place that switch in place. And so when that occurs, what should happen is that 1 should be passed through to Q, and the 0 should be passed through to 0. Now in this case, the high is going to provide us a voltage, and this note, the lamp here is illuminated. And if you had gone in, if you go in and do this simulation and you set this to 5 volts here, you'll put a low here, and then if you supply a clock, if you go to 5 volts and then back up to ground, you should change the state of your light bulb here. And I encourage you to go in and do that with the JK flip-flop. We're going to be doing more JKs that are much more involved in this one, and it's crucial for you to get a basic understanding of how this works, and if you can go in and do these inputs, and you'll get a good feel for how this works. Okay, so this has introduced the JK flip-flop, and we will be doing a lot more with these in future lessons.